morning, guys. We can get started. So what do we think? Did we know how to do these? Yeah, right? What do we get for 1? Good. Okay, so this is the start of our lesson. This is going to be P3. So open these up. P3, it should be titled Polynomials, right? So the slide before this was just explaining the topic of combining like terms. So combining like terms, you can only do so when the variables and exponents are identical. So if you ignore the variables and the exponents, you just combine the numbers in front, right? So 4 and -7 are going to combine to get you -3. -3 plus 9 are going to combine to get you 6. These are like terms because the y squareds are identical, and then whatever doesn't have the variable are also like terms. All right, what did we get for the next one? Okay, what's the first term? 6x to the what? Good. And then what's the x squared term? Good, minus 5x squared. Is there a normal x term? Good, minus x. And then what's left? Good, plus 5. Again, we combine our like terms here. 5x to the third and x to the third are like terms, exact same variable, exact same exponent. We pretend there's a 1 in front and we combine the 5 and the 1. All right, same exact thing with the x squared, 7x squared and 2x squared. The variables and exponents are the same, so you combine the numbers in front, -7 plus 2. Negative x, that's the only x that we see there without any exponent, and then you combine the constants. All right, what about the next one? What's different about that one? Okay, so there's a minus. So what can we do with that minus to make this a little bit easier? What do you think? Okay, yeah, good, distribute. So you're going to distribute that negative to every single term inside. Again, anytime you see a negative, you can treat it like a -1. So this is going to be 2x squared plus 1. The first stays exactly the same. The next is going to be -x squared. It's just going to change the sign of everything on the inside. It becomes -x squared plus 2x minus 1. All right. Once we do this, we can combine like terms, right? What are like terms here? Good, 2x squared minus x squared. What is that going to get you? Okay, good, just a regular x squared, right? 2 minus 1, you ignore the variable with the exponent and just combine the numbers in front. All right, do we have other like terms here? Jet, what do you think? Okay, 1 and -1, what happens to those? Good, right? So these cancel out, and then we're left with just a plus 2x. So I'm going to do plus 2x, and then we get this as our final answer. Okay, so let's continue. We're going to do something similar to this one. Again, keep in mind the sign in between. We are subtracting. So once again, we would distribute that to every term inside. The first set of parentheses we leave alone. Don't do anything to that. So we're going to be left with 7x to the 4th minus x squared minus 4x plus 2. Our next set of parentheses, we're going to subtract, so minus 3x to the 4th plus 4x squared and minus 3x. It just changes every sign on the inside. What are like terms here? Anything to go with the 7x to the 4th? Good, right? So minus 3x to the 4th, what's that going to get you? 4x to the 4th. All right, anything to go with the -x squared? Good, 4x squared, what does that get you? Good, 3x squared. All right, anything to go with the -4x? Good, -3x, what does that get you? Good. And then anything to go with the 2? No, so we just write plus 2. And then there's nothing more we can do, so then that's our final answer. Not bad? Good. All right. Next one looks slightly more complicated just because there's more groupings. But again, order of operations, we're going to work on the inside first, and then we'll look on the outside. All right, so let's look at this big bracket first. All right, let's work in here. In here, is there anything we can do with these two binomials that we're adding?
You can only subtract 7 from 1.
Okay, good. So our only like terms here are 1 minus 7. Y squared doesn't have any like terms, so that's going to stay y squared. 3y also doesn't have any like terms. It's just going to stay 3y, and 1 minus 7 is going to get you negative 6. And this was all still in this bracket. And then I'm just going to bring the rest of it down. Y to the third plus 1 minus this whole thing. All right. And then just like before with the past few problems, this minus we can distribute to every single term on the inside. This is going to get us y to the third plus 1 minus y squared minus 3y and plus 6. All right, do we have any like terms here?
Yeah, only the 1 and the 6.
Good, all right, so we can do 1 plus 6. We're going to get y to the third minus y squared minus 3y plus 7. All right, not bad. Good. Okay, next little section is we're going to multiply polynomials. So if it's a binomial times a binomial, this is what you guys know as foiling, right? So binomial, if you remember, bi means 2. So that means if you have 2 terms times another 2 terms, that's where you can do your FOIL method that we did in some previous lessons with the radicals, all right? But otherwise, you're just going to take each term and distribute it to each term in the next polynomial. Let's say if it's 2 terms times 3 terms, right? We'll get there. Okay, so let's give some of these a try. Okay, everything on this first page is going to be very similar to one another. Just because we see parentheses, what do we see outside of all of these parentheses? How many terms?
1.
Just 1 term, good. So how do we handle just 1 term on the outside of a set of parentheses? Good, right? We're just going to distribute it like normal. So when we distribute, keep in mind, this is where our rule of our exponents comes in. When you're multiplying with the same base, you add those exponents. So this is the same as 3x to the third, because this has an exponent of 1, this one has a 2, minus x squared, x times x is x squared, plus 1 times x is just 1x. So then we get this as our final answer. We don't have any like terms to combine. All right, 7 and 8 are pretty similar, so I'm not going to spend too much time there. What's the difference with number 9? Okay, so it's in parentheses also. Where is it? Is it at the front like the other ones were?
In the back.
No, this one's in the back. Right, don't let that confuse you. It's still the exact same process. If it's just 1 term, you can distribute it to each term in your parentheses. So we get 2 times 2y to the third, which is going to be 4y to the third. And 2y to the third times negative 3y is going to be negative 6y to the what?
4.
To the fourth. Good, guys. All right, let's try some of these. Again, I'm not going to spend too much time here just because they get pretty repetitive. I'll do 10 and 13. Okay, so what's different about these? It's how many terms times how many terms? 2 terms times 2 terms, right? Good. So this is where we FOIL, right? We do our first times our first. X times x is what? X squared. X times 4 is what? 4x. Negative 8 times x is what? Negative 8x, good. And then negative 8 times 4 is what? Negative 32. Okay. Do we have any like terms we can combine here? Good, right? So I can do 4x minus 8x. So this is going to get us x squared minus 4x minus 32. We'll get that as our final answer. All right. Again, I'll skip around. Let's try 13 now. All right, so 13, we can do the same thing. What's our first times the first? Good. So this is going to be 28x squared. It's our outer times our outer. Outer times outer is going to be negative 21x, right? So the outer here times the outer here. All right, what's our inner times our inner?
21.
Okay, I got the 21 and then minus 8x. All right. Looks like you jumped a little ahead, which is fine. Negative 2 times negative 3 is going to get you positive 6. So that's our last times our last. All right. And then from here, when we combine like terms, that, yeah, right, is going to get us negative 29x. So we get 28x squared minus 29x plus 6. All right, not bad. Good. All right, so these ones might get a little bit more complicated just because how many terms do we see in each set of parentheses? Good, right? We see 3 terms in each set of parentheses. Couple ways you could go about this. I personally like to take the first set of parentheses and then take term by term. This is going to go to this entire thing right here. I like to write it out. You might be able to do it all in one go, but I like to write it out. This is the same as x squared times this whole thing, x squared plus 2x plus 2. And then I do the same thing with the second term, right? Negative 2x is also going to go to this whole thing right here. So it's going to be minus 2x times the whole thing again, x squared plus 2x plus 2. All right, and then I do the exact same thing with the last term. That plus 2 is also going to distribute to this entire thing, which is going to be plus 2 times x squared plus 2x plus 2. All right. And we handle these piece by piece, right? So I'm going to start with the yellow, and we're going to take that x squared and distribute it to all 3 of these terms. So this is going to get us x to the 4th plus 2x to the 3rd plus 2x squared. And now we can take that negative 2x, distribute it to each term inside. That's going to get us a negative 2x to the 3rd minus 4x to the 2nd minus 4x. And then lastly, we can take that 2 and distribute it to each term again, and this is going to be plus 2x squared plus 4x plus 4. All right, so we should have 9 terms so far. Some people can go from this first step right here to this right here. That's perfectly fine. I like to be careful, and I like to show the step before it. All right, what's left to do here? Combine the like terms, right? So we have nothing with the x to the 4th. That's going to stay the same. Do we have any other x to the 3rds? Okay, good. So I see a 2x to the 3rd, and then I see a minus 2x to the 3rd. What happens there? Good. All right, so I see a 2x squared. Do I see any other x squareds? Good, right? So I see the minus 4x squared, and then I see the plus 2x squared. All right, so what happens with those? Good. So these cancel again, right? 2 plus 2 is 4, and then 4 minus 4 is going to get you 0. What happens with negative 4x plus 4x? Cancel out again. Good. And then we're only left with the 4. All right, so we had 9 terms just a second ago. And after combining our like terms, now we only have 2. All right, that doesn't happen all the time. Sometimes it does happen. When it does, it's really nice when things cancel out. All right, but we're okay with that one? Okay, so I'll let you guys try the next one. All right, I'll do it the exact same way. I'm going to take that first term, distribute it to this. So that's going to get us 2x squared times this trinomial. Then we're going to get a negative x times this trinomial. And then we're going to get a plus 4 times this trinomial. So plus 4 times x squared plus 3x plus 2. All right, in yellow, I'm going to distribute that 2x squared. That's going to get us 2x to the 4th plus 6x to the 3rd plus 4x squared. After distributing that negative x, we should get negative x to the 3rd minus 3x squared minus 2x. And after distributing that 4, we should get plus 4x squared plus 12x plus 8. Is that what you guys got so far? Good, nice. And then from here, we just combine like terms. Nothing combines with 2x to the 4th. You leave it alone. 6x to the 3rd minus x to the 3rd is going to get you 5x to the 3rd. 4x to the 2nd minus 3x to the 2nd is going to get you x to the 2nd plus another 4x to the 2nd is going to get you 5x to the 2nd. And then we get negative 2x plus 12x is going to get you plus 10x. And then lastly, we have that plus 8. So we get 5 terms here. You guys get that? Okay, these are some special products. You don't have to memorize them. You really could just work it out every single time. But it helps that you do memorize them just because it makes some problems a lot faster. Definitely this first one, the product of a sum and a difference, is super quick and easy to memorize. If you have a plus b times a minus b, it's the same as a squared minus b squared, which, if you guys remember, is the exact same property that we used when we rationalized something like that, right? When you guys did the conjugate 1 minus the square root of 2, this is the exact shortcut that we were using to multiply that, all right? But if you square a binomial, right, some people will distribute that square. That is not correct, right? You do have to FOIL it out, so don't do that. FOIL it out, and then you're going to get this term in the middle that most people miss, the plus 2ab and then the minus 2ab. The 1s to the 3rd power, right? Not a lot of people memorize these, right? There is, I think when you guys get to pre-calculus, right, there's something called Pascal's triangle. It's this little triangle right here that relates to your coefficients. You don't have to write that down. It's not important to you guys right now. But something like that does help you with higher powers in binomials, right? But again, anything to the 3rd power, you guys could memorize these. It would make it a little bit easier, but you don't particularly have to. You could just write it 3 times and then multiply it. All right, so let's try some of these here. Let's try 16, right? Does this look like it would be a special product? Yeah, right? What's making it a special product? Yeah, right? So it looks exactly the same, right? So I have a 2x and a 2x, a 3 and a 3. One is a plus, one is a minus. So you can use a special product and just square the first minus square the second. Right? If you memorize that special formula, you don't have to FOIL it. You can just get your answer pretty quickly. This is going to get you 4x to the 2nd minus 9. All right, on that note, what would the next one be? Quickly, what do we think? Okay, what's our first term? Okay, what's that going to, in our special product, what's that going to get you? 16a squared, right? You're going to square everything. 4a times 4a is going to get you 16a squared minus, what's our second term? Good, 25b squared, right? That is our special product. You could FOIL it if you want to, but it's always going to work out this way. If it's the same terms, 1 plus, 1 minus. All right. Now, when you have something like 6x minus 5 squared, right, most people choose to FOIL this. I would say it's pretty helpful to know the special product, right? Some people see the special product and they think, oh, that's too hard to memorize. I'm just going to FOIL it. But once you do memorize it, it saves you a lot of time, right? So how would you guys solve this, let's say, without the special product? FOIL it, right? You would do 6x minus 5 times 6x minus 5. And then when you FOIL it, what is your first term? 6x times 6x, what does that get you? Good. Outer times the outer, 6x minus 5 is going to get you negative 30x. Inner times the inner is going to get you negative 30x. And then the last times the last is going to get you plus 25. Notice here you can combine negative 30 minus 30, and that's going to get you, good, right? So you get 36x squared minus 60x plus 25. All right, so again, there's nothing wrong with that. Just in time, you're going to want to know some patterns just to make some problems a little bit quicker. So I'm going to do the next one using the special product. Remember, the special product when it's a minus b squared is the same as a squared minus 2ab plus b squared. In this case, a is going to be our first term, b is going to be our second term. So all we're going to do is we're going to do 5 squared, so square the first. And then at the end, I'm going to do plus 8x squared, square the last. Multiply 5 times 8, which is 40x, and then double it. So negative 80x. And then once you simplify this, you get your answer. So 25 minus 80x plus 64x squared. All right, so you can see once you get a special product, should make it a lot faster than FOILing. And that's a good point, right? So maybe you want to write it as 64x squared minus 80x plus 25, right? That's also perfectly fine. One thing to note, this right here is in standard form. It's not particularly necessary for this lesson to have it in standard form, but it's good to get into the habit of writing it in standard form just because in the future that's going to help us a lot. So standard form is when the highest exponent is first, and then the constants last, and the exponents go in decreasing order. So x squared, x, and then the constant. This is in standard form. For the sake of your test next week, I'll take either one. All right. I'm going to do 1 to the third power, so I'm going to try 22. All right. Our rule for the third power, again, you don't have to memorize it if you don't want to, but sometimes it is better that you do. All right. So the first term is going to be a to the third minus 3a squared b plus 3ab squared minus b to the third. So you can memorize that and then just plug in the first term and then plug in the second term. Or if you don't want to do that, you could write it 3 times and multiply. Just when you do it this way, you have to do it piece by piece, right? You can't multiply all 3 of them at once. You might confuse yourself. So let's say you did choose to do it this way, that you wanted to write it 3 times and multiply it. You would FOIL 2 of them first and then distribute the next one, right? So if you FOIL the first, you get x squared minus 2x plus 4, which is going to get you x squared minus 4x plus 4. So that's just for two of them, but then you still have this third one. This is going to be x minus 2. And then you can multiply this exactly as we did before, so you can distribute that x, or that x squared. So it's going to be x to the third minus 2x squared. You can distribute that negative 4x. That's going to be negative 4x squared plus 8x. And then you can distribute that 4. That's going to get you plus 4x minus 8. And then when you combine your like terms, you should get x to the third minus 6x squared plus 12x minus 8. Okay. I'll do these two and then we'll be done for today. All right, this one's a typo. This one should say 3a to the power of 2. So that should say 2. All right, this one is a special product again, right? Keep in mind this is the product of a sum and a difference. So I have 3a squared, 4b squared, and 4b squared. I have a minus and a plus. So we can do our special product. This is going to be 3a squared minus our next term is going to be minus 4b squared. All right, and then when you square that first term, you're going to end up with 9a to the fourth. Minus, when you square the next one, you're going to get 16b to the fourth. Again, if you don't choose to do that, you can FOIL it if you want to. But you're going to find it helpful to memorize your special products. All right, what can we do with the next one, 24? Do you notice anything there? Okay, good. So this first two is a special product. That's going to get you x squared minus y squared. All right, and then we have this still. This is going to be x squared plus y squared. And then notice that this is another special product, right? It's still the same exact terms, 1 plus 1 minus. So this is going to be x squared, which is to the fourth, minus y squared, which is to the fourth. So then we get that as our final answer.